Hello and welcome to this week's episode of the iTnews podcast. Our guest this week is Jason Streatfeild, who's the Substation Design Manager at Essential Energy. This is a bit of a departure from our usual IT strategy and architecture discussions, but it's an interesting line of work. Essential Energy is using drone-captured imagery and software to create intelligent three-dimensional models of substations that engineers can interact with and plan upgrade works for remotely. We hope you enjoy the conversation.
Can you give us a brief overview of Essential Energy and the area of the business that you work in?
Yeah, so Essential Energy is a New South Wales government-owned electricity distributor that covers 95% of New South Wales and some parts of southern Queensland. Overall, there's 1.4 million poles across 737,000 square kilometres. So it's covered a large area, and across that area as well, we've got nearly 400 substations supplying more than 840,000 customers. I work in the network design branch of the business and manage a team responsible for completing the designs for projects to construct new or upgrade existing substations. So those substations, nearly 400 of them located all the way across New South Wales. In major areas, there's one per suburb. In smaller towns, there's normally one per town. My team of engineers and engineering officers and drawing officers manage all aspects of substation design. So we look at everything from the civil, roads, footings, drainage, buildings, primary high voltage plant layouts and connections, and our secondary electrical schematics and wiring diagrams.
Fantastic. So you mentioned there that you are looking after both greenfields builds as well as upgrades of existing sites. Can you give us a sense of the work volumes that you might see? And I don't know what on scale you want to put on per month or per year, given it's a construction and design area.
Our work volumes do change a lot. It depends on what constraints are found through our planning teams and where our work comes from. But predominantly over the last 6 or 7 years, the majority of our work has been brownfield work on existing substations. A lot of the network in New South Wales was built quite a few years ago, and unfortunately a lot of the infrastructure is ageing at about the same rate. So we're doing a lot of work, especially in our regional remote areas, replacing lots of different equipment in existing sites. Obviously, over the last 20 or so years, we've done a lot of work at those sites where we've upgraded the drawings as well or improved the drawing quality. We very rarely in the last few years have been building any greenfield sites, but a lot of those are probably coming along in the last 12 months with our increased solar connections and wind farms.
So can you talk a little bit about that? Because I think it's an area that perhaps our listeners wouldn't be familiar with. There's this process of updating drawings and better illustrating the specifications to which that substation was built. There would be parallels within the information technology area and particularly within software development in terms of creating better documentation, for example, to accompany software. But I think it would be useful to just understand your particular area and particular line of work.
Yeah, so I'll run through pretty much what has been the process for many years, especially for our primary plant replacement projects. So that's all of our equipment that's in our substation yards, inside the big fences, our transformers and our circuit breakers and structures. So a lot of the times it would mean that we would need to go to site, take a lot of measurements, confirm what drawings that we had were accurate, confirm that the construction was accurate to the original design. And all this was done for a variety of reasons. The main one was safety. We need to ensure that we design our equipment to the right clearances so that we can ensure that when teams need to work on them for maintenance and operation, that they can do it with absolute safety. And we've got to abide by Australian standards and our other standards for each of the areas. We also want to make sure that it's structurally sound and that we've got fit for purpose electrical connections for the right voltages, for the right current, for the right load. So we've spent a lot of time over the past 20 years travelling, going to site. Sometimes we need surveyors to actually plot points for us to make sure that we can get everything that we need. Take a lot of photos. And then every time we do a project, then we were trying to upgrade the majority of the drawings for that site so that we knew exactly what we had. And then those drawings were drawn on CAD systems. And for us, that was Bentley MicroStation. And then what we thought at the time, we would come away with what was really an industry standard of having CAD drawn drawings to a site that was as accurate as we could get. What that meant, though, was it was a lot of time and effort checking the existing equipment and then drawing it, often a little bit of backwards engineering as such.
Okay, so you've basically gone to a lot of sites over a number of years and you've basically done this reverse engineering. You've got these more accurate drawings. Can you talk a little bit more about now how those drawings are stored and what you're able to do in terms of the system? And I think that's partially what we might be able to talk a little bit about more today.
Yeah, so this was a process that we were using for a long time, and those drawings we created, stored in our ProjectWise drawing management system, which we have it set up with workflow approvals so that we can ensure our quality and our accuracy. So we would go through separate steps where we would issue the drawings for comment to the field, and then we would have any markups or any questions. We would then review them internally and then approve them so that it was all recorded down and that we could have some audit trail of how we issued our drawings to the field. And it took care of all of our version control. So there was never a drawing that went out of the same version with different information on it, which was really key. That's the basis of a drawing management system. Today, we're going to talk a bit more about our next step. So this was really our first step in moving to digital drawings. Our next step was really making the drawings intelligent. And that's where we really have taken the next big step in design.
Tell us a bit more about that. How do you make drawings intelligent?
We started looking a few years ago to what options there were available. We understood that there was a product called Bentley Substation 3D, and it had been out for quite a few years. And it started to link your drawings and your equipment that you wanted to place on that drawing to a database. So if you placed a transformer on your drawing, then that project included that transformer and all the information about that transformer. So it was starting to show some intelligence. Instead of just having lines and circles and text on a drawing, you're actually placing real equipment that was linked to a database. When we first looked at it, we probably weren't quite in the position to really invest our time and effort into moving forward. But about 4 years ago, I decided it was time that we needed to draw in 3D. We needed to understand the intelligent design system and that we could really prove that the efficiencies and the improved accuracy was really what we needed to do to move forward as a team. And at the time, Essential Energy, like I think a lot of industries, needed to be more efficient. So this was our small way for my team to really make a difference. At the same time, as we really started to get into understanding Bentley Substation 3D, the context capture program became available to us. And it highlighted the area where we were most lacking in moving forward, which was having the ability to quickly and easily create a 3D model of our existing site. So in essence, context capture was the game changer in our brownfield designs. It allowed us to go and call up one of our drone pilots that are regionally based across the state, go and fly around a substation for somewhere between 2 hours and a day, take several thousand photos, send them back to my design team, and then we would internally process them using context capture into a reality model. That reality model, to scale, in most cases millimetre perfect, allowed us to answer every question we ever needed on that site. It allowed us to import that into our Bentley Substation 3D design package as the basis of our design. And we knew exactly where all of the existing equipment was, and the detail on it was as such that we could zoom in and read nameplates. We could understand what the equipment was, and it really just reduced our need for our site visits and a lot of the time taking measurement or taking photos or going back and asking again for another photo because we missed something. So we ended up incorporating all of these systems together. We're using now context capture to provide us with a reality model. We're then using Bentley Substation 3D to create our new design. We remove the piece of equipment from the reality model that's going to be removed in real life. We insert in our new intelligent objects, all the connections, everything else that goes with it. And then we create a combined drawing using both of those products. And the output for us is fantastic because it's reducing our time for design. We know we've got all of the correct clearances. We've got all the other advantages of an intelligent system. It has lots of design engineering built into it. We can do lots of things from lightning protection calculations, which are done really at the click of a button instead of 2 or 3 days of an engineer poring over a calculator. It knows what equipment we put in our design, so it automatically gives us a bill of material, even counting up all the nuts and bolts and washers. It counts up all of the lengths of conductors and how many meters we use to join all of our equipment together. All those things are automatic. It just saves us so much time in checking and rechecking and making sure that we're doing the right things. So for us, it was a game changer. And then the final little part of our intelligent design system for substation design was really making it a full end-to-end process. So with the upgrades to ProjectWise Connect for our drawing management system, it's now a cloud-based service with lots of other functions that allow us to write some rules. It allows us to be a lot more imaginative about what we want to happen to a drawing when we approve it. So, for instance, we can automatically rendition our drawings to PDFs as soon as they're approved. We then transfer them automatically to a SharePoint folder, which is accessible via Microsoft Teams to our construction team and our zone substation construction teams in the field on their iPads. And that's an automatic process. And as soon as they have a question on that drawing, it comes straight back to us. So we've created a lot of efficiencies in not needing to print, not needing to do a lot of the manual checking and reviewing, and a full end-to-end process for us, which is repeatable and accurate.
It sounds amazing, some of the connections there. I felt like you were almost underselling it in terms of saying this is something small that you were able to do for your part of the organization. It seems like there's a huge amount of technology complexity that has gone into this, from the drone capture of the images to the assembly to the output.
It has taken a while to do this, and I have to admit we're very proud of our system. It's working really well. To date, we've created approximately 20 major projects using this system over the past 18 months, which is about $20 million worth of projects. It's been a learning curve. Obviously, every time you implement new systems or processes, it takes a lot of time and effort to set up the training and the documentation and maybe change some business rules, which all takes time. But the systems themselves are the core of it, and just putting them all together into a process, that was the eye-opener of getting that end-to-end process together. You could just see the benefits of the systems and how they work together then.
The other thing you mentioned was the millimeter accuracy of the capture and the creation of this model. You mentioned one example, I think, that you could read the nameplates from where you're sitting. Have you got any other examples that might illustrate work that you would undertake that needs that kind of resolution and accuracy to be able to do it from remote and not have to do a truck roll?
Yeah, so every time we want to do even the smallest of jobs, the smallest of design projects at any site, if we're replacing equipment and that equipment is on an existing site, it's mounted on a footing, it's on a structure, it's bolted down, it's got a particular connection points for cabling or for bus bar. So we can zoom in on a lot of our models now and actually determine the spacings for the bolts. This one might be 50 millimetre spacing, something else might be 60. We can determine that on a live bus bar 6 metres in the air. We need that sort of clarity on pretty much every job we do. To be able to get it from a model, from a drone flight, or maybe incorporating some ground photos as well, is just incredible for us. It's a game changer. We know what equipment we need. We don't have to leave anything up in the air for the construction teams to sort out on site, because we might guess the wrong size or have to provide alternatives for them, whereas we can get it right first go, which is fantastic.
Yeah, I can completely understand that. It's an amazing result from this. One thing I wanted to ask was the move from 2D to three-dimensional design. Was there any sort of learning curve for you and your team in terms of moving to that different way of representing substations and substations under design?
Absolutely. We had only really drawn in 2D. We'd looked at it a couple of times in 3D, didn't see the benefits until we could see this system. But Essential Energy has spent a lot of time and effort in their drawing quality for many years, and the training of our drawing officers. And they're dedicated drawing officers. They don't do anything else except draw, so they get to understand the systems completely. And for that team to be able to upskill to 3D was quite an eye-opener for me. I thought it was going to be a huge step, but in reality, they took it on, and it really was one of the easiest steps in the entire process, was learning 3D drawing. They just took it on really quickly. I think that was also one of the major things that allowed this to work well. Having proficient drawing officers that are dedicated to it was a big step forward.
What excites you about the next 12 months? And that could be changes or enhancements within your area or line of business. It could be some additions to what you're doing within this particular ecosystem. I'll leave it up to you as to what excites you.
There is a few things that are exciting myself and my team at the moment. One of them is that we're in the process of purchasing new drones and cameras. So we're pretty excited about what sort of improvements we're going to get in our 3D modelling capability. It's really stepping up from the small, almost hobby drone to the professional, commercial quality drones and cameras. So for us, I think that's going to be really exciting to see what detail we can get. We're also continuing to develop Bentley Substation, the system itself. But at the moment, we're proficient in the primary design and we're still developing the secondary design. So we've got a lot of work yet ahead of us as a team. We believe we've got lots more to learn, lots more efficiencies to gain. But my biggest thing I'm looking forward to is really continuing to work with my team and the willingness that they have to implement change and the enthusiasm they've got to find new ways. Really, they're the ones driving the change now. They're pushing me, saying, we want this done quicker. Let's get it going. So for me, that's my challenge, is to keep up with them now.
That was Jason Streatfeild from Essential Energy, and that's the podcast for this week. We'll be back with an exciting new interview next week. Until then, you can catch all the latest headlines in Australian IT over at iTnews.com.au.